Okay, we're going to start talking about 6.4. We're talking about scientific notation. I want to write an example of scientific notation up here before I start talking about it so it makes a little more sense. Okay, what you see is a decimal that is smaller than 10 and it's actually bigger than 1. And so how do I know that? It's this right here. See the decimal point? It's the number in front of the decimal or on the left side of the decimal. 4 is bigger than 1, obviously, and it is less than 10. So what I'm looking for is a single digit. I don't need two numbers here. I just need one number here that fits in that position and has a decimal that follows it. Okay. Also, this is not x, it's times. So we've got 4.24 times 10 to the 6th power. So this whole piece, that whole thing that I have written on there, is your scientific notation. So now that you know what it is, I want you to realize that the rule is actually about this number right here. It has to be greater or equal to 1, and it has to be less than 10. Okay, so all I'm saying is it has to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Can't be anything else in this position, okay? All right, so let's go on. I'm going to write a couple more rules. So this is rules from a decimal. So from a decimal to scientific notation, if we move the decimal to the left, the exponent will be positive. If we move the decimal to the left, the exponent will be negative. So this is what we do when we move the decimal and the exponent. And you know what an exponent is. Remember x to the positive 2 or x to the negative 2? It's not going to be an x, it'll be 10, okay, because that's part of the rule. It says that 10 goes right here. And so 10 will be this number here. Instead of x, it'll be 10. But these exponent positives and negatives comes from this rule right here, okay? So if you were given a decimal, and let's say that it wasn't actually a 4 here, what if it was actually 42.4? Well, you know I'd have to move the decimal to the left to make it be that 4, right, to fit the rule, because 42 is bigger than 10. So I need this number to be less than 10, so I have to move the decimal and it becomes 4.2. Since I moved it to the left, since I went to the left, that means the exponent's going to be positive. It would actually be 1, positive 1, because I only moved it one place. But we'll get into that in this next example. All right, so if you are starting with scientific notation, okay, we'll come back to the rules for decimal, starting with a decimal, but we're starting with scientific notation, and I'm going to write the same exact example that I just gave you. If you start with scientific notation, you follow the rules of the exponent, okay? What does that mean? That means that is a positive 6. Which direction on a number line is positive? This way. So that means I'm going to put my pencil on this right here, and I'm going to move it 6 positions towards the positive area. So here's what this looks like. 1, 2, 3, 4, 5, 6. Here's my new decimal. Why am I counting between the numbers? Because the decimals only go between the numbers. I needed to move it 6 times in the positive direction. Positive, talking about a number line. If this is 0, this would be 10, this would be negative 10. I'm going in the positive direction, so I moved it to the right 6 positions. So that's where I counted 1, 2, 3, 4, 5, 6. Put the decimal right here because that's where I counted 6. And what goes in these blanks? Zeros. They're placeholders. So if I change this problem from scientific notation to a decimal number or to a whole number, my final answer for this one is going to be 424 with 1, 2, 3, 4 zeros. And then we put in our commas and put in our decimal. Commas go between the numbers every 1, 2, 3, comma, 1, 2, 3, comma, okay? But your decimal will go at the very end. So this is my final answer. From scientific notation to a whole number, to a decimal number, You look at the exponent. If it's positive, you go in the positive direction. If this was a -6, we would go in the negative direction. We would just put our pencil on the starting decimal and go whichever direction we want to go. Okay, let's try another one. So let's do the same problem, but with a negative, and see how that changes our answer. If you start in scientific notation to move it into a decimal number, you follow exactly what the exponent tells you. So I write my number, put my pencil on it, and I count 6 positions towards the negative area. So 1, 2, 3, 4, 5, 6. Decimal, fill in all of the blanks. So I have decimal, 1, 2, 3, 4, 5, 4, 2, 4. Final answer. You don't get to ignore anything. You have to keep everything that was there, but we just now have to have decimals as placeholders to move our decimal over that -6 positions, okay? All right, so now back to the rules that I gave you a second ago. If I start with a decimal and I need to go to scientific notation, I look at this and I ask myself, for this to follow the rules for scientific notation, it has to be a whole number that is 1, 2, 3, 4, 5, 6, 7, 8, or 9. So if I move this decimal here, did I get the number here that I needed? No, it's still 0. If I move it here, I still have 0. If I move it here, I now have a whole number of 3. So this is where I want my decimal to go. So how many times did I move it? 1, 2, 3 times. Okay, so I moved it 3 times knowing that my exponent is going to be a 3. My question now is it a positive or is it a negative exponent? Well, we're going to go back to those rules that I gave you in the very beginning, right here, sorry. And it tells me that if I go to the left, it's positive, and if we go to the right, it's negative. So let's go look. I went to the left, I'm sorry, to the right, so to the right would be, to the right would be negative based on those rules. So let's go back and look at the rules, make sure I said that right. If we move to the right direction, it's going to be negative. Okay? It's kind of the opposite of what you would think. So if we're talking about a number line, if we move right, we don't go to the negative. So they're kind of the opposite of what you think they should be. The opposite of what you think they should be when you're starting with a decimal, okay? Scientific notation, when you start with scientific notation, you do exactly what is in the exponent. If you're starting with a decimal, you record the opposite of what you do, okay? And if none of that makes sense, then just write that little chart, the arrow with the symbol with it, and you'll know what you have. Why does this work? Because when I look at this problem as my final answer and I say I have scientific notation, the rule for scientific notation is look at my exponent and do exactly what it tells me. And it says move 3 in the negative direction. On a number line, this way is negative. So if I go 1, 2, 3 in the negative direction, I ended up with exactly what I started with. Okay, so that's why this does work. Okay, but I want you to see that 3.27 times 10 to the -3 is my final answer. Okay, so let's try another one of these because I know sometimes they're confusing. Let's do 1, 2, 4, 8 decimal. Okay, I need to move into scientific notation. 1,248 is not a scientific notation number. I need to move the decimal over as many times as I need to until I get to this 1, 2, 3, 4, 5, 6, 7, 8, or 9 number I need. So here's the number I ended up with. I couldn't stop right here because I would have 12, and 12 is bigger than my 9, right? Has to be under 10. So this is where I stopped. So if I count, I counted move 1, 2, and 3 places. So I have times 10 to the 3. Did I move to the left? Yes, I did. So that makes it a +3. So my final answer is 1.248 times 10 to the 3rd power. It does not need that plus sign on there, okay? It's understood to be plus. Okay. All right, let's go to this one. So now we're trying to separate the rules. We started with scientific notation. The rule is look at the exponent, do exactly what it tells you. Here's the exponent. I want to move in the negative direction, which means to the left. I put my pencil on this. I move it 1, 2 places, and I put a placeholder. My final answer is that. How come I counted 2? 1, 2, because this guy right here was a 2. We went negative in the negative direction because it was a negative 2. Okay, move on to something a little more difficult. We're going to start multiplying, and we'll talk about these answers in just a second once I get the problem written up here. So 9.405 times 10 to the first power times 9.5, oops, sorry, didn't mean to write that parenthesis, 9.5 times 10 to the 5th. Okay, so what do we know? We know a couple of things. First of all, I'm going to write this in red because this is just a multiply sign, okay? I could take it out and put a dot between them if we wanted to. I'm going to leave it in simply because that's scientific notation format and I want to leave it. But here's what I have. I have 9.405 times 10 to the first power times 9.5 times 10 to the fifth power. Everything is multiplied together. The x and the dot all mean the same thing. So every one of these pieces are multiplied together. I really don't need the parentheses, okay? So what I'm going to do is I'm going to multiply the things together that match. These are whole numbers, I will multiply them. These two are also like terms. Just like we learned yesterday, if I had a problem like this, you would not hesitate to know that you are going to have bases that match, so you bring your base over. It's a multiplication problem, so you're going to add your exponents. And so you got this. Here's what I want you to see. It's okay if it's an x, but it's also okay if it's a 10 because the bases match, so you bring your base over and add your exponents. Okay, it's the same principle. It's not just a letter in that rule. It can go anywhere. As long as the bases match, you can bring the base over, okay, and then add your exponents. So I already did this for you, but I want you to see that these two together give you 10 to the 6th power, okay? Now let's go back and use our calculator and let's multiply 9.405 times 9.5 in our calculator. Okay, when I did that, the answer that came out for me, I'm going to write the whole thing. It ended up being 89.3475, I believe. And then, you know, we have this multiply sign times 10 to the 6th power. Okay, now, if this is a whole number that is 1, 2, 3, 4, 5, 6, 7, or 8, I'm sorry, 8 or 9, anything that's between 1 and 9, right? It can't be 10, has to be smaller than 10 to be scientific notation. If it is, we're done with this problem. But I realize that 89 is not in between 1 and 10. So I need to move that decimal one place to the left. I do know, remember, that if I have a decimal number and I move the decimal place one place to the left, it's like moving it a positive one time, right? Remember there was a relationship between left and positive for the exponents. So now I have 8.93475 times 10 to the what? Well, I already had 6. I moved it one more time, so now I have to the 7th power. So this is my final answer. Okay, I multiplied the numbers and I got this. I multiplied my bases with exponents and I got this 6 plus 1, which gave me 10 to the 7th. So that's where they came from. This did not follow the rules yet, so I had to move it one time. That's where I got this plus 1 exponent from. Oh, sorry. That was supposed to be a 6 right there. So here's what I got. And then I took that 6 here plus the 1, and that's where I got a 7 from for a final answer in the final answer there. Okay, let's move on and try a division one. And let's look at that. 4.466 times 10 to the 4th power divided by 1.62 times 10 squared. Okay, don't want these to think that they're x's. They're actually multiplies, so I'm going to write them in red so you don't confuse them. Division. we are actually dividing. So here's my first problem. I read from top to bottom. I push divide in my calculator and then type in the bottom number and then push equals. Okay, when I do that, I end up with 2.756790123 and I know I need to round that, and it'll tell me what to round to, but usually it's 4 decimal places. This guy makes this one round up, so I'm looking at 2.7568. We're done with the numbers, okay? We've done all of this work. Now I'm here. I have bases that match. It's a division problem, so I'm going to keep my base, and I'm going to subtract my exponents. Remember, we learned that in one of the earlier sections from this unit. So 4 was the top number, so it went first. 2 was the bottom number, so it went second. So 4 minus 2 gives me 10 squared in the numerator. It is positive, so it doesn't need to move. It's just going to stay there. So I have 2.7568 times 10 to the second power. Final answer. Is 2.7568 in the numerator as well? Yes. Anytime we do a division problem, the answer is always in the numerator. So yes, very good. Okay, that wraps up all of your stuff that we are working on for section 6.4. Make sure that you do your TOYOs and ask me if you have any questions.